Okay, welcome everyone here and abroad. So this is the first time that we're really trying to stream a seminar. Thank you very much for everyone attending. So what we're going to do is Peter's going to give sort of two relatively short talks of 15 minutes each. And the idea is that anyone, if they have any questions, of course here they can ask very easily. If you're not here, if you were to either use the Twitter hashtag or email myself, the chair, or just send an email to the list, I suppose, but maybe to myself directly would be better. I've sent an email around just recently about that, so you could get my email from the email I've just sent around. And then at the end of each talk, we'll sort of field the questions, have about 15 minutes, around 15 minutes after each talk for questions, and then move on to the next talk. Okay, well, thank you very much, Peter, for giving your seminars, and I'll pass the mic back to you.
Thanks, Robin. Okay, so these are practice rounds, so thanks for coming along. They're not going to be very technical talks. I'm going to present them in 2 weeks' time at the International Population Data Linkage Network conference in Swansea. So that's a user conference. Many people from governments, from the health area are coming to the conference. And as Robin said, these are very short, non-technical presentations, but if you have any questions, we can talk about them later on. So the first one is work I've been doing with people in Scotland, actually in Cambridge as well, trying to link historical data, specifically birthdays, marriage and census, records from the Isle of Skye. And this work is funded by different projects. Digitizing Scotland is one, and the Administrative Data Research Centre Scotland, and also the Simons Foundation and the Isaac Newton Institute here, which funds my stay here in Cambridge. So what do we want to do? Well, linking historical data, there's a shift in the social sciences from analyzing small data sets about a small group of people, maybe based on surveys, on data collected specific for a research project, to take whole population databases and link them together to build pictures about families and households, and basically then use that information to do whatever social sciences are doing, which I don't know much about. Still not. So if we are able to link data together over a certain period of time, we sometimes call this population informatics. We can build something which we call the social genome. So you're familiar with the biological genome. The social genome is basically all the interactions we would have as individuals with society. Of course, in the past, there wouldn't be that much electronic information, but still we would have registry information such as birthdays, marriage, and also censuses recorded over a long period of time. If we are able to link individuals and families over longer periods of time, then we can do all kinds of studies about fertility, employment, education, health, crimes, and so on. That's kind of the aim we want to do here. The project I'm talking about today is a very small, fairly small data set from the Isle of Skye in northwestern Scotland. We want to link them automatically, so in an unsupervised way, without learning parameters and linkage, the linkage itself. But this is a prototype for hopefully ultimately linking the whole data of Scotland together once we get access to the whole of Scotland or parts of it. So what are the challenges of linking historical data? The picture at the top is, I think from the United Kingdom, a census record from 18 whenever. I can actually read it from here. So what the challenges are, we have low literacy of people who filled in the records or the certificates. We have recording errors, we have transcription errors. People didn't know the exact date, there were no standards in address or occupations, so the data is really messy. What we're also dealing with is that, specifically in the data set we're having, is that a large proportion of people had the same name. Very small name pool, there were many Marys and many Johns. Of course, then we also have the issue of people moving out of a certain area, immigration, emigration. We have to deal with people dying somewhere else, people being born in another area of Scotland. And then we have the technical issues of scanning and optical character recognition errors. And the last one is of course the dynamic nature of households and families and how they change over time. So all these things make linking historical data more challenging than just maybe linking a contemporary data set, which is recorded at a single point in time.
In Scotland, they also all have the same last name, right?
That's right, yes. So,
sorry, I'm not sure if streaming is working again, but we should probably just keep going and
I
try and
keep
sort it
going.
out for the next talk.
Okay. So basically what we're trying to do at the end, we want to find live segments, and we try to visualize those here. So every horizontal dotted line corresponds to a person. Every circle corresponds to an event where we have a record for. So you can see the first line at the top is a male. We give them a number. We have a census. We have a marriage of that person, the birth of a child, another census, and then a death record of that person. The vertical lines show that every horizontal line corresponds to a person. The vertical lines show the people who are together on a single certificate. So for example, a census certificate, you see this whole family here is on a single census certificate. For this birth of the child, we have the father, the mother, and the baby here. So these three people are on a certificate. So basically using the certificates, we're trying to generate these live segments. And we do have a set of these live segments which were developed over, I don't know how many years compiled how many years by domain experts. So Alice is one of the people here. The important thing is that we don't use these live segments as a training set to learn the linkage parameters. You only want to use that for evaluation. We want to have a fully unsupervised automatic linkage system at the end. So this is how our certificates look like, and these are some of the links which we could, or the role pairs which we potentially could use. So we have birth, marriage, death, and census. Census has not just one person, but that's the role a person can have. And these are just kind of some of actually these are all of the potential ways of how we can link between different certificates. So for example, we could link a birth to a marriage. The baby becomes the bride, the baby becomes the groom, the baby becomes the bride mother, and so on and so on. And the aim is that we're looking at potentially we're linking individuals to build a very big graph where the nodes are the certificates and the links between the certificates are the similarities which we have. And I'll come back to this a bit later on. So we have different types of roles across the certificates. An individual's roles over time is changing. So baby becomes the bride, then becomes the bride mother. We have many linkage constraints. So a birth can only be linked to a single death. So there's only a true link, but a baby can have, a mother can have several births and so on. And there's also temporal constraints of how we can link records between certificates. So this is kind of an overview of the individual steps we've implemented in this prototype. I'm just going to go through them fairly quickly. So we have our certificates, we do some cleaning, we put everything into the same structure, into this common schema or table. So we can actually compare individuals, so about records about people. Then we do a blocking, so we don't want to compare every record. We don't want to compare John Smith with Mary Miller, so we kind of look at people who have the same name or live in the same parish or have the same address and things like that. But again, we take all the rows into account. We're never going to compare a female baby with a husband and things like that. So otherwise, we're going to have way too many records which we have to compare. The third step then is a pairwise similarity function. Again, people at the conference will be very familiar that we kind of do string comparisons, so we compare Mary with Marie, and John with Johnny, and we get again basically that very large graph where we have similarities between individual people. This is all standard linkage so far. The next step now is basically trying. So here we get here we link many more certificates together than is actually possible. So we have what we call a very high precision. A very low precision, but a very high recall. So we're able to get most of the true links in that pairwise attribute similarity step, or we have way too many. So what we do in step 4 is now trying to reduce these many links into the true links, and it's very challenging. Oops, that's too fast. What's going on here? Okay, the second part of our approach is now these two more advanced steps, the relational similarity step and the group linkage step, and these are really state-of-the-art computer science techniques of linking complex data. The relational similarity basically looks at the ambiguity of, let's say, for example, a name. If there's somebody called John Smith, there might be lots of other John Smiths in the database. So it's kind of not clear if we link two John Smiths that they are the same person. But if you have two people with a very unique name, then the ambiguity is much smaller. So we kind of look at the neighborhood of similar records, and again, we can use that to do a relational similarity, as we call it. Then the group linkage step basically calculates similarities between certificates by taking the similarity of individuals into account. So if you have a baby has a similar name as the bride, and the baby's mother is the same as the bride mother, the baby's father has a similarity with the bride's father, then we can calculate an overall similarity. So we do this individually, so the relational step and the group linkage step are done independently, and then we fuse them together. And at the moment, this is a simple averaging. Again, this is something which we can improve as well, with maybe give different weights. And then the last step then would be to generate these live segments or maybe family trees. Okay, so how does the data look like? So this is just a summary of what we're dealing with. So we have birthdays and marriage. So we have certificates, and because on the certificates there's more than one person, the number of individual records, the number of people is much larger than the number of certificates. So we're dealing with roughly 250,000 records about individual people, and we're not going to use all of them. We also, as I mentioned before, we have something like 55,000 live segments. So these are manually prepared, manually or semi-manually or semi-automatically linked ground truth data set, where about 19,000 of those are single certificate only, so they don't really contain a link. And there's also, because the way the domain expert did that linkage, there's a kind of a bias, so it's a skewness towards certain types of links. So most of the links are towards census. So for example, birth to census, census to census, and census to death are the most common links, while links between death and marriage are very small. Okay, so how do we evaluate linkage quality? So this is what we do in computer science. We calculate precision, which some of you might know as the positive predictive value, and recall, which is sensitivity. So basically, precision measures how many of the classified true matches divided by all classified matches. So high precision means of the linked records, many are correct. High recall means many of all the true links or the true matches we have, many are included in the class of the true matches. And in order to combine them into a single measure, many of you might be familiar with the ROC curve. We calculate in the area under the precision recall curve, which is illustrated up here. So what about the results? So as I mentioned before, it's a challenging domain, and the results are not as good as we hoped. And after having actually a long discussion with the domain experts, I don't know why, and I'm working on improving these things. So the important thing is that the higher the bars are, so these are just example results, these are initial results of some of the experiments. The higher the bar is, the higher this area on the curve is, so the better the results are. So we're looking at different types of certificates, and we also looked at, does it make a difference by modifying the similarities by including missing values or not. The important thing is that a standard pairwise linkage, which what a standard piece of software will do, doesn't work at all. Right? It gives you very, very low linkage quality. The group linkage does a bit better. Relational similarity, these are different ways of how you calculate these relationships. Does better with certain types of similarities. The fusion gives us much higher result, but still not as high as we hoped for. Out of time. Same for birth and census. Census to census works pretty well, but as you can see, census to death doesn't work well. You have to look at what the reasons are here. But again,
can you just explain why there's those differences between include and exclude? I mean, sorry if I'm messing your timing up. But,
yeah.
Why is it that all the excludes are higher than the includes?
So if I exclude the missing, if I exclude the missing values, I kind of increase the similarities by not. So if I include a missing value, let's say I have 5 attributes. If I include a missing value, then I kind of say that's a similarity of 0. So I kind of lower the average similarity. If I exclude an attribute, then I kind of only consider values which are not 0. Which are not empty, and that gives me potentially a higher similarity between 2 records.
And then
that makes sense.
It switches when you go on to the next.
You mean the previous one?
Well, it says REL. Is that the relational?
Sorry?
The relational ones, then they switch the opposite way.
Yeah. Again, that's something which we still have to look into. What the reason is, I'm not sure. The relational don't. Again, the relational similarities are based on the pairwise similarity is the only one where we change the similarity between 2 records. So there's so many different variations, and it's really some work, some don't work at all, right? So many things we would have to look into to check what's really going on here.
Is this a result of a simulation?
No, this is on the data. This is really.
So how do you know if you did the correct? How do you know the curve? How do you know?
Sorry. I think I mentioned that here. So I calculate this compared with the live segments, which we assume is the ground truth, which is not fully a ground truth. So this is comparing with what was linked by the domain experts, by the demographers. So Alice has done a lot of linkage. So kind of trying to find out, can we automatically find exactly the same links as what they did with a lot of manual work? That's kind of the aim. And as you can see, there's still lots of work to be done. So what are the conclusions? Linking complex data is very challenging. I didn't expect to get results which are that low. So these are really the state-of-the-art computer science-based linkage techniques. Pretty much taken the algorithm as presented in papers and implemented them. Doesn't seem to work right. We need a lot of customization and a lot of discussion with the domain experts, what they actually did. So we need to develop new techniques which really look at the domain. And the next step which we're going to do is looking at, instead of looking at individuals, we're looking at triangles of people. So a baby and its parents will become the bride and the bride mother and the bride father, kind of looking at them as an entity instead of having 3 people. So we want to improve all the steps of our linkage approach. We also want to look at specific census to census subgraph linkage, so where we kind of look at families which stay the same because they're changing over time, how we can take these changes into account. And then that's the last step, well, one of the last steps to do is kind of looking at can we take the dynamics into account when we do the linkage, and there's still lots of work to be done. Okay, that's the first talk. Thanks for
So I have a question.
and questions now.
Is it okay now?
Yeah, please. I'm trying to sort out the streaming, so the longer we can have a bit of time. So does anyone have a card? Sorry, while you do that, because I couldn't get into. I forgot to bring my card with me, so I was trying to track down someone here, but there's no one around. And email them whether they'll come. Do you want to see?
But it's being recorded, at least.
At least, well, let's hope
If
so.
you
Did you mean this guy?
Yes, sorry. Thanks. I was just going to try and bring someone. But before the next talk.
So when you did the linking, computerized linking, you did not look at what the expert did.
That's right. Yes.
But actually, if you think the expert is an expert, maybe the right way is to take a training set at least and match the expert and learn from that. If this is your goal, if this is the standard.
The problem is because we want to employ techniques on the whole of Scotland. If we learn on a small set like the Isle of Skye, we learn a statistical model on the distribution of names and all these things. We don't know how good it is going to be on the whole of Scotland. So by trying to have an unsupervised, not learning anything, but comparing it with the manually linked data, then at least we know how good we are on the Isle of Skye. That gives us maybe an estimate of how good we might be on the whole of Scotland.
I assume that usually when people construct expert systems, which is what this is, they take into account what the expert would have done or
Yeah,
does.
that's what we're doing. So we had a meeting early this week. So the idea is really, and again, I've started this roughly about a year ago, and I basically decided to start with a computer science approach, a state of the art, and see how good, which has shown to work very, very well in other domains like bibliographic data. How good do they work on such historical data? And as we see,
Would
they
it
don't
not still be methodologically interesting to actually try out some sort of supervised approach?
Oh,
Say
definitely.
just
I'm not saying
taking
this. Yeah, that's right.
10%
Yeah,
of the data
Yeah.
for the training set
Yeah.
and then
I mean, I did at some stage actually I did a bit of work using a support vector machine. One of the problems is, and that's again in the details, is because many when we calculate the similarities, and because so many people who are not the same have high similarities in their names or they live in the same village, we actually get different people who have very high similarities in their characteristics. So even for a support vector machine, it's very, very difficult to get high accuracy, or for any supervised technique. Because for almost even, so if you normalize similarities between people into 0, 1, and you have different characteristics, even for highly similar links, many are non-matches. That's different than if you would link contemporary data where people have many more different names, right? But in our data set, it's such a skewed, I don't know what is it, 30% are John McDonald or something like that, is it?
It's not that high,
But it's
25% American John.
Yeah, and it's only like seven parishes, is it?
So from a methodological point of view, you might think this approach of having just a single link and so on is a bit limiting, but statistically one might have some uncertainty about which is the correct link, and that one might want to, I don't know how one deals with that uncertainty, but at least...
That's right, I think that's the idea with, again, what's happening here? That was the idea with using the relationships, and I mean, there's so many more technical details involved. The relationships, for example, also looks into like, if I have to, let's say if I have a birth and I have a death, so that birth had 2 parents, and the death has 2 parents as well. How many marriages would they have in between? If they have, let's say, 5 children, maybe 4 got married. So you got that relationship that you have links to 4 marriage records. That was kind of the idea as well. So that's kind of one of the, where was it? That's kind of, I think that's the other, which kind of coming from social network analysis, to look at these relationships and neighborhoods and take the connectedness into account.
Were you talking about giving a probability to the link or something
It was
along those
more
lines?
like that, like
Yeah.
in this sort of multiple imputation approach, instead of having a single set of links,
Yes,
you
you had
might
far
have
more
a
links,
set
but some
of
of them,
cases where there's a whole lot of McDonald's that you can't differentiate between.
Yeah.
You might in your multiple imputations.
Yeah. So that's one option. That makes it problematic depending on what you want to do with the data. Because if you want to then create longitudinal data from this,
Then
where you follow people over time,
Mm.
you can't really do that, because then you basically get a whole load of different possibilities, and it becomes very, very difficult to do any meaningful analysis on those. So I think it's
But
ideally from analysing the finished linked data set, you rather avoid that.
Yeah, but arguably from an analyst's point of view, it might not be a bad thing to at least be able to flag up cases where
Yes,
the
absolutely.
links
yes.
are pretty,
Yeah, but
uncertain.
better to get to yes, absolutely. So you want a score for various things, but better to have a situation where you can replicate, or where you can better replicate the links that that we've made, in which we are fairly certain.
Did you try to compare 2 experts, or even one expert doing it once and then resting for a month and then doing it again?
It takes far too long for that. Besides, it took us years to,
Oh, really?
Because it's a data set of, it's a small data set compared to the whole of Scotland, but there are lots of, there are lots of things, and you have to do it all iteratively. So you have to take out the really certain links, and then when you've taken those out, you have a set of you've reduced the possibilities for the other links and so on. So it's not something which you can do and then redo to see if you get a different.
But two people could do it in parallel and then we
Yeah,
could
well,
compare.
they could, but the funder wouldn't give us the money to do that.
Hiring 100 PhDs rather than undergraduates. Okay. Did you get any questions on Twitter? Or?
Well, the streaming hasn't worked.
Hasn't
so
worked.
sorry.
Is it working
yeah,
now?
no.
Or?
Sorry.
Is it working now?
No, I mean I've told them and they looked at no, there's a problem. So they're trying to contact Jonathan at the moment. I mean really I'm not sure what to do. I mean we could just press on and just have the talk, but I don't know if it's going to be resolved in the next 5 minutes or not really.
Well, last time it took 2 days to resolve.
Do you want to do it tomorrow?
I'm not
Are
here
you
tomorrow.
Are
I'm
you
not
here
here
tomorrow?
tomorrow.
Oh, you are.
I'm not here tomorrow, no, sorry.
Yeah, it's a shame really. I mean the second time this has happened and they were quite certain this time it would be fine. I mean it's just really it's out of our hands at the moment. It's going to be recorded hopefully.
Yeah, well, it's been recorded. So everybody who has a question out there, send me an email.